Today we're going to cover the cost of production, or cost of doing business. It is important to understand, if we want to understand a firm, it is very important to understand the cost. So, total cost is the market value of the inputs a firm uses in productions. So we all know that when a firm produces goods and services, so-called output, okay, the output doesn't just come out of nowhere. Okay? It is produced using inputs. Inputs, as some of you may call in other courses, factors of productions. They are resources that are used to produce goods and services. For example, raw materials. Okay? For example, if you want to make a shirt, for example, you need cotton, that's a raw materials, and you need a sewing machine, that's capital goods and services. So machines, equipment, and most importantly, workers. Okay? So these are inputs or factors of productions, and they all cost money. So the market value of the input a firm uses in production gives us the total cost. The more output a firm produces, the larger amount of input it employs, the larger the total cost, holding other factors constant. Okay? So that should make sense. I mean, if we want to produce more output, we do need to use more inputs. So that gives us a larger total cost. So next, we're going to look at the production function. Okay? So in order to understand how much input we need in order to produce a certain amount of output, okay, or if we have a certain amount of input, how much output can we produce, we need to study the relationship between input and output. And we can do that using the production function. So the production function shows the relationship between quantity of inputs used to make a good and the quantity of output of that good. So let's look at a schedule or table. So this is a production function of inedible bakery. So the first column gives us the amount of inputs. So in this case, that's the number of workers. The second column gives us the quantity of output. In this case, that's the quantity of cookies produced in an hour. And then, well, we'll leave the third one to later. So using the first column and the second column, we are able to plot the production function curve. Okay? So this is how a production function curve looks like. So the quantity of output on the vertical axis and the quantity of input, in this case that's the number of workers, on the horizontal axis. Okay? So then using the table, we can have several data points here. When the company hires no workers, we get no cookies. When the company hires 1 worker, we get 50 cookies in an hour. 2 workers, 90 cookies in an hour. And then 3 workers, 120 cookies in an hour, and so on and so forth. So this is a typical looking production function curve. As you can see, it is upward sloping. So mathematically, we all know that upward sloping curve, or positively slope, means that the quantity of output is positively related to the quantity of input here. So that means as the quantity of input increases, the quantity of output increases, which should make sense. The more workers we hire, the more cookies we get to produce in an hour. Okay? So that gives us a positively sloped production function curve, upward sloping. But there's another thing that we observe. So you can see that as the number of workers increases, as the amount of input increases, the amount of quantity, the quantity of output increases. However, it increases at a decreasing rate. So it's a little bit of tongue twisting here, right? Okay. So when we have more and more workers, each additional worker can add to the total production, but it adds a fewer amount than the previous one. So in layman's term, the subsequent worker is less productive than the previous one. Okay, so when you look at the curve, it is not linear. It is what we call a concave curve. Okay, so that means the slope becomes smaller and smaller. So what does the slope represent? So we learned in math class that the slope is rise over run, right? So pick any 2 points, rise over run. When you look at the vertical distance, the rise is the change in the quantity of output. And the horizontal axis, the change in the quantity of input. Okay? So that means the slope is the quantity, the change in the quantity of output divided by the change in the amount of input. Okay? So that's the slope. Right? So what does that mean? The change in the quantity of output divided by the change in the quantity of input. So basically what that means is how much each additional unit of input adds to the total production, right? Okay. So that gives us marginal product, MP. In some textbook, you see the term marginal physical product, or MPP. So they are the same. So the marginal product of any input in the production process is an increase in output that arises from an additional unit of that input. Okay? So basically, it's a change in the quantity of output divided by the change in the quantity of input. So that means the slope of the production function is the marginal product of the input. In this case, that's the labor. Okay? So you see that the marginal product of labor decreases. Decreases. The marginal product of labor decreases as the number of workers increases. And that is probably clearer if you look at the table one more time. Okay? So as the factory, the bakery, goes from 0 to 1 workers, you can see that the total production or total output increases by 50 cookies. So that means the first worker adds 50 cookies to the total production. So that's the marginal product of labor of the first worker. And then when it goes from 1 worker to 2 workers, the total production goes from 50 to 90. So that means the second workers adds 40 cookies to the total production. So that's the marginal product of labor of the second workers. And then when we go from 2 to 3, okay, so the change in input is once again 1 worker, and the change in the quantity of output is 30. Okay, so 120 minus 90. So what that means is the marginal product of labor of the third worker is 30. So you can see a decreasing marginal product of labor as the number of workers increases. So what does that mean? Okay. So that gives us the law of diminishing marginal returns, or the law of diminishing marginal product. It is a property whereby the marginal product of an input declines eventually as the quantity of the input increases. So that means each additional unit of input becomes less productive than the previous one. Okay? So you can see the keyword is eventually. That means it doesn't have to kick in right away. It doesn't have to kick in the beginning of the production. So the marginal product of an input could increase in the beginning, but eventually it will decline as the quantity of the input increases. As more and more workers are hired at a firm, each additional subsequent worker contributes less and less to production because the firm has a limited amount of equipment. So why do we have the law of diminishing marginal product? So just imagine a very small factory. So initially, the owner hires one worker and work with one machine. So one worker, one machine. So we have a total production. So and then the owner decides to expand. So now we have two workers, okay, one machine. So the second worker may actually, the second worker adds to the total production, okay? In fact, in some cases, we may actually observe the second worker, adds to the total production more than the first one, because now, instead of working working alone, feeling very lonely, they now each have each other's company, so they're happier, they may work faster, okay? So maybe. So as the owner continues to expand, so now the owner hires the third worker. So now we have three workers working on one machine. Okay? So the third worker may still add to the total production, but he probably will not be as productive as the previous two, because when you look at these three workers, they have to take turn to use one machine. Okay, so at one point, at least one of them will have to sit there, doing nothing, and waiting for his turn to use the machine. So this is a loss of productivity. Okay? So that's why the third worker is not as productive as the first one. He does not produce as much, or he does not add to the total production as much as the first two workers. So if the owner continues to expand, so you can see that now we have four workers working on one machine. That could be a problem, right? Fourth worker definitely is not as productive as the first three workers, because now they're really running out of space. They're also running out of machines, because they have to wait for a pretty long time for their turn to use the machine. Okay, so that is not productive. In fact, in some cases, we may actually expect the fourth worker to bring in negative marginal product. Okay, that means maybe he doesn't add to the total production. Not only that he doesn't add to the total production, he may actually reduce the total production. Okay, because this factory is too small. They run into each other. Okay, so they are in each other's way. They're not happy, so they fight with each other. They don't get along, so it becomes counterproductive. Okay, so the law of diminishing marginal returns occurs when variable inputs are combined with a fixed amount of another inputs. So when you recall the story of this small factory with only one machine, the variable inputs here is actually the worker. So we can keep increasing the number of workers. But there is at least one type of inputs whose amount is fixed. In this particular case, that's the machine, and also the space of the factory. Okay, so in this period of time, okay, for whatever reason, the number of machine and the space of the factory cannot be changed. So as we keep increasing the number of workers, which is a variable input, each subsequent worker becomes less productive than the previous one. That's how we get the law of diminishing marginal returns, and it occurs only in the short run. For our purpose, for now, you can think of short run as a short period of time where we cannot change the amount of at least one type of input. Later on, we will give it a more proper definition. Okay. So that brings us to the types of inputs. So just now in the factory, in the example of the factory, we have, two types of inputs. So the worker is a variable input, meaning we can keep changing the amount of workers. And then we have the machine and the space of the factory, which is fixed inputs because they don't change. Okay, so fixed inputs are inputs whose amount is fixed regardless of the amount of output. Variable inputs are inputs whose amount varies with the amount of output. Okay, so accordingly, so fixed costs are pretty much costs that are associated with inputs. So fixed costs are those costs that do not vary with the quantity of output produced, whereas variable costs are those costs that do vary with the quantity of output produced. Okay, so total cost can be divided into two types of costs: fixed costs and variable costs. For the sake of time, we like to use shorthand, FC for fixed costs, VC for variable costs. Sometimes you also see total variable cost, total fixed cost. Okay, so total cost is equal to fixed cost plus variable cost. Okay, total fixed cost plus total variable cost. So let's look at an example. Okay. So let's look at an example. So we have in the first column the quantity of output, and the second column the quantity of input. In this case, that's workers. And as you can see, this is a variable input because the amount of workers increases with the amount of output. And then we have fixed costs. Okay, it may be the rent per hour, rent of the bakery an hour, or rent of the machines, or cost of the machine, and so on and so forth. But it is fixed. You can see that regardless of the change in the quantity of output, the fixed cost stays the same. Okay, so and then we have variable cost. So in this case, each worker costs $10 an hour. Yeah, so each worker, the wage is $10 an hour. So when the company hires one worker, the variable cost is $10. And when the companies hire two workers, the variable cost is $20. So when you look at the relationship between the quantity of output and fixed cost and variable cost, okay? So when the company produces nothing, the fixed cost is still there, okay? Because you still have to pay the rent, right? Even though you produce nothing, you still have to pay the insurance, even though you produce nothing, right? And so on and so forth, okay? And then variable cost, if you produce nothing, you don't have to hire workers, so we get 0 here. So the total cost is the sum of fixed costs and variable costs, so that gives us $30. So when the company produces 50 cookies, okay, 50 cookies, it hires one worker, okay, So that the variable cost is $10, and then the fixed cost is $30. So the total cost is 40. And then when a company produces 90 cookies, it hires 2 workers. So the variable cost is $20, okay? And then the fixed cost is $30, okay? And then the total cost is 50, and so on and so forth, okay? So now we can plot the total cost curve, or sometimes it's simply called the cost curve, okay? So when you look at the total cost curve, the vertical axis is always the total cost, and then the horizontal axis is the quantity of output. Be very, very careful here. At the very first glance, the production function curve may look very much alike, okay, to the total cost curve. Okay? But when you look at them carefully, you can see the difference, right? With the total cost curve, the vertical distance is the total cost, right? Whereas production function is the quantity of output, right? With the total cost, the horizontal axis is the quantity of output, whereas with production function is the amount of input. So we have to be quite careful here. So the total cost curve, this is a typical looking total cost curve. It is upward sloping. What that means is the more output we produce, the higher the total cost, which should make sense, right? So the more output we produce, the more inputs we use, so the total cost increases. Okay, so this is a typical looking total cost curve. Okay, before we move on to another topic, I would like to very quickly discuss with you the type of fixed cost and variable cost. So let's look at an example. Okay, so suppose you want to open up your own family-run coffee shop. Okay, coffee shop. So what are some of the example of fixed input? Okay, or fixed cost. Okay, if that's what you prefer, right? Okay, so some of you may think of what. So let's just give it a couple of minutes. So let's pause the video, okay, for a couple of minutes. Let's think about some of the examples of fixed inputs or fixed costs, fixed and variable inputs for coffee shop. Okay, let's pause. Okay, some of you may know that fixed inputs, it could be the equipment, right? The coffee machines, right? Okay, because you don't really change the number of coffee machine that frequently, right? Okay, and then what else? If you serve sandwiches and stuff, there's a fridge, right? All right, okay. Equipment and appliances, okay. So then what else? You can think of the furniture, all right? Okay, and some of you may want to add the rent, okay? So whether you have good business or bad business, you still have to pay the same amount of rent, okay? The insurance, right? Okay. Okay. And then some of you would think of, like, how about, salary, right? So when it comes to salaries and wages, it really depends on which type of employees, right? So if we are talking about waiters or waitresses or servers, okay, usually when you run a restaurant, for example, you don't hire as many waitress or waiters or servers during off-peak hours. And so, for example, if you are the busiest during lunchtime, okay, or dinner time, okay, you usually have more waiters and waiters during those few hours. You don't have as many in other off-peak hours, right? Um, and then so and oh sometimes you may figure out you may figure you have the most business on weekends, so you have the most shifts for waiters on weekends, not as many on weekdays. So that means it varies. Okay. So when it comes to waiters, servers, it does vary. It is a variable input. But when it comes to administrative and management personnels, it's a different story, right? For example, marketing expenses, it probably doesn't vary as much with the amount of business you do, right? Whether you serve 100 coffee today or 0 cups of coffee today, you still tend to spend a certain amount of marketing expense. And you hire an accountant, okay, whether you have good business or bad business. You have a store manager, whether you have good business or bad business. So it depends. So the administrative staff tends to be fixed inputs, right? And then we have variable inputs, right? Some of you can think of, we just talk about it, right? The waiters, okay, and then the servers, right? Okay, okay, okay. And then what else? The ingredients that goes to the coffee, right? Coffee beans, all right? The more coffee we serve, the more coffee beans we need to use. And then we have all the supplies, right? The plasticware, right? Okay. The cups, and then napkins, and so on and so forth. Okay. Some of you would say utilities. Utilities is a little tricky. For the most part, you can say, especially this is a restaurant business. It really depends on the type of business. If it's a restaurant business, you can pretty much argue that utilities like water, electricities, they are variable. Okay, so because the more coffee you serve, obviously the more water you use, the more you run the machine. Okay, but as some of us who pay attention to the utilities bills, then you know that there is a minimum charge, or they call it the surcharge, or things like that. There's a minimum threshold that you actually have to pay regardless of the amount of the water or the electricity that you use. So that's the minimum amount. So it's pretty much fixed. And also, when you look at, if you're looking at an office business instead of restaurant business, the utilities is pretty much fixed, right? Um, Whether it is a good business or a bad business, right? So so in that case, you will have to give it a little bit more thought. But in restaurant business, yes, to a large extent, utilities, okay, may be quite variable. Okay.